Hello everyone, welcome to GE103 Introduction to Programming and Data Structure course. So in this course we'll study how to write program in C language, and then we'll understand the basics of data structure, and we'll also try to write some program or data structure program in C programming language. So first we have to understand what is C programming, and most of this course, almost 70% of this course is only based on C programming, where we will try to understand how to write a program in C. And then the next 30% is to understand the basics of data structure, and then how to write a C programming for data structure, different data structures. Okay, so why this course is important? I think this point is not required to explain you now, because you guys are not new in IIT system. You already know the importance of a programming language, and especially the programming language like C, because this is the most basic programming language, and this type of programming language is required for your most of the work during the BTech and even after BTech. So I hope you already understand, realize the importance of a programming language like C. So I'm not explaining it in more detail that why this course is important and how tough this course is. So this is a very important point. Here I like to mention you that the course will not be tough much, but you have to be very you have to follow my lectures, and you have to follow my instructions, and you have to sit in all the quizzes, and you have to submit all the lab assignments. Then it's not a very tough thing. So for the first and last time, I'm using a word here, and I'll never use this word again in throughout the course, and that is called backloggers. So because it's true that the course is for backloggers, but I'll never treat you that you have already did not able to clear this course for once. I'll not consider all these things, but please remember that there was something happened with you, and you did not able to clear this course in previous attempt. So I hope you will not repeat these mistakes here. If you repeat this mistake, then again there will be problem. I don't want to fail anybody, but if you don't follow my instruction, then there will be difficulties. So that's why how tough this course is. This point is important for you, and I'm again saying that if you want to clear, or if you want to get a good grade, everything is possible, but you have to follow my lectures. Plus, you have to submit the lab assignments. You have to sit in the quizzes. All these things are important, and your marks of each assignment, every lab, all these things will be updated just from the next day of that quiz or lab. So you have to follow all this thing, and if you think that your marks is not going good, give some more time on this subject. Let me know where are you getting difficulty to understand. All these points are very very important. Again, I'm saying this, that if you are not following my lectures throughout the semester, then at the last point, don't come to my office, or don't call me that I want pass mark. That is not possible for me, but I will try to make you try to make everybody pass in this course by giving some easy assignment, giving some easy quizzes, easy questions. That I can do, that I will do. But always remember, even to solve my easy questions, you have to follow my lectures. Okay, and these are some important rules. Weekly videos will be uploaded on YouTube. I'll send a YouTube link. All the links will be uploaded on Google Classroom. You have to follow my Google Classroom. Outside Google Classroom, there will be no notifications. Maybe sometimes I'll send some email, but mostly all the notifications and every lectures will be uploaded on Google Classroom. So follow my Google Classroom, and lecture duration will be 30 to 40 minutes. Yes, I'm not uploading lectures for 50 minutes that usually a lecture should in IIT, 50 to 55. But why? Because here I am not asking any question to you. I'm not listening any question from your side. I'm not answering any of your queries. So it just I'm saying and you are listening. So I think in this mode, even a 30-minute lecture is equal to a 50-minute means offline lecture. So that's why my lecture duration will be up to by either 30 to 40. If I see that I have recorded a lecture of more than 40 minutes, then I will divide it into two classes. Okay. So another thing, the third important point is reading textbook and watching online lectures. Both are important for you. In the next slide, I'll show you the textbook that you have to follow. I hope if you search it, you will get the PDF also for this course. So reading the textbook that I'll give, it is important. You have to read the book, plus you have to listen my lectures. Both are important. And also please remember, separately I'll not provide any other slides to you. Why? Because if I provide slide, then there will be three material: textbook, online lecture, plus slide. Everything is not required. My entire class will be based on a book. You have to read this book line by line, then everything will be understandable for you. Plus you follow my lectures. Even after this, if anything is not clear, you can always ask me. So how to contact with me? You can contact with me via Google Classroom. But if you want to send me a private email, that then you can send me a direct email in my Gmail account. Okay. And in any quiz or in MedSam or EndSam, question may come directly from the topic that was discussed in lecture videos. Maybe I'll not say that when I'm uploading a video, when I'm saying something in my lecture videos, if I have said something in my video, I'll not specifically say that this point is important for your exam. But if you are not following my entire lectures or all lectures, maybe you will miss some point, and maybe that particular thing will be there in some quiz or exam. So please follow my lectures. And the next thing is, there will be two TAs in your course. They will mostly handle the lab assignments, which I'll explain in next slide. But the most important part is, do not argue with the TAs. If you think that any TA has not evaluated your program properly and you deserve a better mark or better grade, then let me know. Just send me a mail, I will handle it. But do not argue. If you argue with my TA and I got any complaint, then I may deduct your marks also. So if you are not satisfied with the TA evaluation, try to explain them. If you think that you have done a correct code but they are not understanding it, try to explain it. Try to explain it to them. But if they are not getting your point, it may be possible because they are also human beings. So in this case, let me know that they are not understanding your point. I'll try to solve it, but do not argue with them. This course should start from this week, but since today is Sunday already and I'm uploading just the first lecture, so in this week there should be three lectures, but instead of three lectures, I'm uploading only one. So what I'll do, I'll try to I'll make up this three lectures in next week, or maybe next week. So in next week, that is from tomorrow, I'll upload four lectures instead of three lecture, and again in next week I'll upload four lectures. In this way, I'll try to make up this week that has already spent for all these registration issues that you already know what happened. Yeah, and one last point that I forgot is, during any exam, that means any exam, that is whether it's maybe a quiz, it's maybe a mid-sem, end-sem, lab assignment, if I found that you are copying, then 0 marks will be awarded. So there will be no argument, there will be no request I will entertain. So don't try to copy. Okay, so the next slide is about the course details. So the class structure, there will be two modules in this course. There is theory, there are three classes per week, lab one per week. So in theory, there will be 70 points out of 100. There will be 70 points in theory. So and in lab there will be 30 points. So how this the 70 points of theory is distributed? So in just to concentrate on theory part. In theory part, if you see, there are quizzes, 20 marks per quiz. Let me set a pointer. It should be laser pointer. Okay. Yeah. So theory, there will be 70 points. So out of these 70 points, there will be 20 points for quizzes. So there will be each quiz, there will be 2 to 4 points. So there will be many quizzes. At least there will be 7 to 8 quizzes will be there in this course. So these quizzes are excluding the whatever the quiz mentioned by academic section. So these are extra quizzes. So every quiz have some marks, 2 to 4 points. You have to sit for the quizzes and you have to collect those points. These points are very important for you because there are 20 points only in quiz out of 70. Mid sem there will be 20 points, and sem 30 points. Okay, so this is how I'm distributing 70 points from theory part. Now coming to the lab part, you can see there are 30 points in lab. So again, this is very important for you. If you are and weekly, there will be assignment for lab, and these part will be completely scheduled or completely managed by the two TAs. So they will send you a mail how they want to means conduct this weekly assignments. So the basic rule is every week they will send a question to you. You have to write the program, and then they will evaluate it. How they will evaluate and which platform you have to write this code and everything. These everything will be explained by my TAs for you. So weekly there will be assignment, and you have to write a program. That's it. So there will be many assignments. So if assume there are n labs throughout the semester, then the average of best n minus 4 assignment will be taken. Okay, so assume that if then throughout the semester I have taken 10 labs, so out of 10 labs, average of best 6 will be taken. Okay, so this is how the lab points will be calculated. There will be no separate mid-sem and end-sem for lab. Only weekly assignments will be there. So please be means concentrate and do all the weekly assignments. Okay, and now the total score. Total score will be theory plus lab. So 70 points from here and 30 points from here. Total is 100, and passing point will be 30. Please note that you have to collect 30 points in anyhow. Less than 30 points will be if you have less than 30 points, I cannot give you pass grade. So please remember it throughout the semester. And it not be tough to collect 30 points if you consider. See, there are 20 points in quiz. So and there will be 7 to 8 quizzes. So if you just sit in every quiz and try to get some marks, at least 1 or 2 marks in every quiz, then also you'll get at least 10 points here. And if you follow weekly assignment in every week, then also you'll get collect some points. So in this sense, I'm giving you, that's why I said it is easy to pass. How? Because I'm giving 30 points here, and there will be every week there are some assignments, so try to do at least something for these assignments. And there are 20 point in quizzes which will be regularly conducting will be conducting regularly. So there are some options. I'm already giving you easy options to get 30 points, which is the passing point. And in there are midsem and endsems also. Okay, textbook. This is the textbook that I will follow, programming in ANSIC 7th edition by E. Valaguru Swami. So I think the PDF of some old version, old edition, maybe 6th edition or 5th edition is already available in internet. You can use this also because but this, if you want to go for this new edition, you have to purchase it online. But the old editions are available in internet. And when I'll start data structure, but data structure part is not starting now, it will start after mid-sem. So at this moment you no need to collect this book, but when we'll start data structure, we'll follow this book for data structure using C by E Valaguru Swami. So these are the course details. So any point if it is not clear to you regarding how I've distributed mark and any other thing, please let me know. You can ask me directly in Google via email or in Google Classroom. So it is better if your question is not very if it is generic to for all the candidates, then all the students, then please ask your question in Google Classroom. Yeah, two, three more points about the lab assignments. So lab assignment will not start, or there will be no lab assignment in next week. That is the week starting from tomorrow. There will be no lab in this week. Why? Because I have not started this course properly. So first I will explain how to write C programming and all, at least basics of C programming. And from next week, the assignment will start. So you have 1 week to understand the basics, how to write a program and all. So it's very easy. I'll try to explain, and you can also follow some other sorts of to start with how to write a C program. So this week I'm not starting live assignment. So this will start from next week. Okay, this is the first point. uh, Another important point regarding lab is, after your lab assignment, every assignment, your marks will be uploaded in a Excel sheet by next day. So for example, suppose today is your lab assignment. So by tomorrow, your marks will be uploaded in an Excel sheet that will be shared with you. So if you have any doubt or any complaint regarding your marks, you have to ask us, or you have to send clear it within the same week, or at least by 4 or 5 days, or we can say that before the next assignment. Before next assignment, if you have any doubt in this assignment, you have to clear it. After this, at the end of the semester, if you say that, sir, my assignment number 5 was okay, but I have they have given me a less grade, these type of requests will not be entertained at the end of semester. So always remember that if you have any doubt, any confusion on any assignment, you have to clear it within this week before the next assignment. So you have to contact with TS, try to clear your doubts with them. If it is not possible to, if you are not satisfied with after interacting with any TS, then you can contact me also. So now we'll start with computer. So maybe you'll ask that why I'm first giving introduction to computer in a course of programming language, because we write programming for computers. What is actually programming? A programming is a set of commands given to a computer to perform a task. So when we write a program, what we do actually, we give some commands to a computer to do some task. So you should first understand what is a computer. Then only you can write proper instruction. So let me give you an example. Suppose you want to move a robot. I hope everyone knows what is a robot. Suppose there is a robot which is some functionality, like it can move front, back, it can rotate 30 and 90 degree, rotate left, it can rotate right, it can uh, so, and you can also apply brake and all these things in a robot. Okay. Now maybe suppose you want to move a robot from this point. Suppose there is a point here and there is a point here. So you want to move this robot from here to here, and then you again want to move this robot reverse from this point, take a u-turn here, and again the robot should come here in this point, in the starting point. So how you will do? So suppose the robot is a remote control robot and you have the remote control in your hand. So first of all, what you will do? First of all, you will start the robot. Suppose the robot is initially in ideal condition, you will start the robot. Okay. So first command you will give is start command. Then next, what will command you'll give? You'll give a command to move forward command. So the moment you'll give forward command from the remote to the robot will start moving in this direction. And you have to continue pressing the forward command until it reaches the destination. The moment it reaches destination, then you have to give it a command to give a u-turn. Suppose the robot has capability to take u-turn, so you'll give a command for u-turn. The robot will take u-turn here. After taking u-turn, you'll give another command to the robot to move again in this direction, move forward. So and now this is the forward direction, like, after taking u-turn. So again the robot will come here, and after returning here, you will give another command to the robot to stop. Okay. So now what you have given, what command you have given? First command you have given start, then you have given the forward command. After reaching the robot here, you have given a u-turn command. Next again you have given a forward command, and after again reaching the robot here in this position, you have given a stop command. So how you are giving this command? You are giving this command because you already know that the robot will understand these commands, right? So first of all, if you want to give some command to a robot, you should know at least the basic functionality of a robot, isn't it? So if you want to drive a car, if you want to drive a bike, first of all you should understand the basics of a car, or a bike. Otherwise, how can you give some command? If you suppose that if you are riding a bike, you want to change the gear, if you don't know the exact functionality of a gear, how can you give a command? So that's why when you are writing a program, first of all, as I have mentioned here, that right, a program is actually a set of commands. You are giving a set of commands like these commands you have given in a robot. So first command you have given is start, then forward, u-turn, forward, and stop. If you write this command one by one, start, forward, u-turn, forward, stop, this is a program. This is a program for a robot in some language. So the same thing is true for computer also. The programming language, the program that we write are actually a set of instructions or set of command that we give to the computer. Why I'm saying commands? Because the computer is already capable of doing all this, executing all these commands. You no need to do anything here. For example, you no need to do any mechanical change in the robot to move it forward. Suppose the robot is already there, you just need to press the forward button. The moment you press the forward button, it will automatically execute. It's know that the moment you give a forward command, robot knows how to move forward. The same thing here in programming language. If you give a command from C language to the computer, computer knows how to execute it. You no need to go and change internally some hardware to execute your program, right? That's why the software and hardware is different. And so whatever write in programming is called software part, and in hardware part means if you do those who have changed who have designed the computer. Or you can say in terms of robot, if I explain that the same robot, that those guys who have designed the robot, they are doing the task of hardware. But if you are designing or if you are writing some program to move this robot forward and backward, then you are working on software part. It's not an exact example, but it's similar. Okay, so that's why the first part here to understand programming is what is computer. So you should understand what is computer. I'll try to explain you or understand you the basic mechanism, internal mechanism of computer in the first and second lectures, so that writing a program should be easy for you. Okay, so what is computer and how computer works? The first line is there is no magic in computer, everything is logic. Computer has no brain. Computer cannot do anything without your command. Okay, same as a gun. Or suppose there is a gun in front of you. Do you think the gun can automatically fire on someone? No. You have to pull the trigger, then only gun can fire, right? So it means that it has no brain. Gun has no brain. It can only follow the commands of you or a person. The same thing is true for computer. Don't think that computer has a brain and computer can and act accordingly. It is not true. People are trying to implement smart computer based, and you know all these big words like artificial intelligence and all, but these are still under research. And I can tell you that everything the computer, most of the computer nowadays, even today, have no magic or no brain. You have to give commands to them for, and they only execute whatever command you give. So maybe you think how is possible computer can do everything. Suppose I just computer can merge the two videos, computer can do a lot of photoshop tasks, like right, for computer, by computer you can edit a photo, everything you can do. So, but actually, internally, everything is just a sequence of command executing internally. And how to write this command is in programming language. Whatever software you are using are written with some programming language. Maybe the program, every programming language is not C, because yeah, writing a program in C is tough compared to other language like Python and Java. But why C is important? Because if you know C, other language will be always easier for you. Okay, so I'll again come back to the programming part later. First of all, let me explain you what is computer and how computer works. So this slide is starting of computers, or you can say that from where the concept of computer comes. The concept of computer started from this guy or this person. Maybe people will have different opinion, but this is according to me that from this person the concept of computer first started, and his name is Alan Turing. Maybe you have seen a movie based on him that is called Imitation Game. This movie is based on his life, Alan Turing. So what this Alan Turing did in 1935, Alan Turing designed this machine. So don't think that it's a physical machine. It's just a theoretical machine, a machine in pen and paper. He modeled the machine in a pen and paper. It's not a physical machine. It's never been implemented. But through this theoretical machine, he explained that whatever algorithm or whatever logic that a person or a human can compute, the same thing is possible to compute by a machine. Okay, but that machine was theoretical machine. But if you see, this is just a imaginary picture of that machine, but this, don't think that this is the image that the Alan Turing has drawn. Alan Turing has given a mathematical model of this machine, but this is just a imaginary figure. So you can see that for this machine there is a tape here, and in this tape there are, you can write something, and there is a mechanism here which can read something from this tape, and that this head of this machine can move either this direction and this direction. So it can read something from this tape, it can write something to this tape, and this head can move either in this direction or this direction from this tape. Okay, so if you see it properly, you will understand that this step is can be considered as a memory of modern day computers. You can consider that this is a memory. Here, all this information are stored, and this head is considered as a computer which is reading data from this memory and doing something, and again writing data here in this memory. So this is called universal Turing machine, which is proposed in 1936. But again, as I said, it's completely theoretical model. So based on this theoretical model, in 1945, almost 9 years after proposing UTM, that is universal Turing machine, another gentleman, von Neumann, proposed this architecture, and this architecture is called von Neumann architecture. So in this architecture, you can see, and okay, the most important part is, even today, almost every computer is based on von Neumann architecture. Whatever desktop, whatever laptop you are using, and even the mobile phone, smartphone of today's smartphone, everything is mostly based on von Neumann architecture. Nowadays, people are trying to do something different from von Neumann architecture, but these are the research under research till now, till date. So you no need to understand all these things, but the truth is, almost every computer, every mobile, every laptop is based on von Neumann architecture even today. So what is von Neumann architecture? You can see in von Neumann architecture there are four major components. This is called central processing unit, input device, output device, and memory unit. Okay, so what is the main concept here? The main concept is, initially everything of a computer will be stored in memory unit here, and whenever you need to perform some task, one by one this memory or this data from this memory will be available here in central processing unit. It will process the data and again write it back to memory. Okay, so okay, the one important thing here is what is called data. I think I no need to explain you what is called data. Whatever information you store in your memory is called data. Now the next question you may ask, sir, what is memory? Memory, I think, in now everyone knows what is memory. If I consider your mobile phone, you know what is memory. Okay, you have a memory, you know how many memory you have, you know how many this SD card, suppose you have 32 GB memory in your in your mobile phone, you know how many memories available in your laptop. Okay, so you know what is called memory. But I'm not, at this point I'm not explaining you the difference between hard disk and RAM. Maybe you, all these things you already know. Even in mobile also there are two things. Home, there are either there is a term called RAM, and then again there is called ROM, or you can say memory card. And if you go for a computer or laptop, there are two things, RAM and hard disk. So but I'm not separating RAM or I'm just saying memory. So memory means RAM and hard disk, everything is memory. So initially, whatever data you want to, whatever information you want to store in computer, actually they are stored in memory. This is true. Suppose you want to watch a movie in laptop. Initially, where is the movie stored initially? Initially, your movie is stored in the hard disk of the laptop, right? So when you first start the laptop, and you then where is your movie is in a hard disk. So now if you want to watch this movie, then what it will do, computer has to perform something. So what computer will do, one by one computer will go to this memory, one by one computer will fetch the content of your movie file, and it will process here, and then it will output the movie file one by one to the monitor, so that you can see the movie. So what I am trying to explain here is that in computer, every data is initially stored in memory. Okay, and one by one, whenever it is required, this data will be fetched to the central processing unit, and the central processing unit will perform some task on this data, and then maybe some result will be returned back to the memory. This is how a computer works. And how input device and output device work: if you want to give some input to the computer, then you have to give it to input device. And if computer wants to give some input to you, then computer will give it through the output device. So this is how a computer works. I'm skipping this slide for now. I'll explain this slide later. So now, if we try to relate this theoretical model again with some real life modern days computer parts, then uh, this is a central processing unit. This is an example of central processing unit. So what is this? It's a processor, Intel i7 processor. So this is very important, and I hope you know all this term already, because suppose you want to purchase a mobile. First of all, you what are the parameters you check? What is the processor? It is the octa core processor, it's a dual core processor, it's a quad core processor. You know what is called processor. If you are buying a laptop, again you will go for you will check what is the performance of the processor. So the processor is the heart of a computer, is the main part of a computer. Okay, so this is the Intel i7 processor. So I hope you know that there is if you want to purchase a desktop, then you can assemble it. You no need to go and purchase a branded desktop. Like if you want to purchase a laptop, you have to go for a particular brand, right? Either for HP, either for Dell. But this is always not true for a desktop. If you want to purchase a desktop, you can always go to a computer shop, and you can purchase you can assemble it. You can purchase different components from different companies, and you can assemble and create a desktop, right? So when you you will go and purchase a processor for your desktop, if you want to assemble, you can purchase separately this chip, and this chip is called a processor. And you can see this is Intel Core i7 processor. There are many other processors for Intel, AMD, but I'm just giving an example that what is called a processor. So this is processor, and this is the main unit of computer. Actually, you can say this is the actual computer. All the computing performs in this part, central processing unit. And if we go for some input device, keyboard is an input device, mouse is another input device. Why? Because you are giving command through keyboard, or even you are giving input to the computer through the through these devices, keyboard, mouse, and all these things. Output device, obviously monitor is the output device, because computer output something for us in through this monitor. Another output device is printer. This is also a output device because computer outputs through this device. Some memory unit, these are the examples of memory unit. What is this? This is a example of hard disk. Hard disk of a desktop machine, mostly this is a hard disk. And what is this? This is called RAM. So I hope maybe you have seen this model in your engineering product. If your engineering product lab is already done, then you should know what is this. This is a RAM, because in engineering product lab there is a assignment. There is a lab on desktop computer. So on that lab, I hope you have seen all these components: RAM, hard disk, mouse, keyboard. These are you already know. Okay, so these are some real means modern day example of these one different components of one human architecture. So combining all these things, you can design a desktop like this. This is called desktop. You can see all the input output things, input component, output component, everything is there. But what you cannot see in this is and memory and CPU. So actually this part, this CPU and these are inside of this box. Okay, so from now onwards, I'll explain some points only considering that this part as computer. Why? Because these monitors and keyboards, printer, these are either input device and output device, means either input or output. So main computer is this. So from here, next point, I'll only consider this as a computer, this as a computer. So if this is your computer, and if you open this computer, it looks like this internally. Okay, so this is a internal this is the inside view of this computer. So if you see it properly, there is a main board here. This is called motherboard. I'm not explaining it in very detail, but at least the basics I'm explaining. This is the motherboard. So on this board all the other components are attached. So Uh, this this is a fan. Inside this fan here, the processor will be there. The example I've shown you now, the Intel i7 processor or any other processor that is called central processing unit. So that processor is installed inside this fan. This fan is just to maintain the proper heat on to this processor. This is a cooling material here, and these are, you can see there are two slots here where you can put your RAM. Then RAM, that RAM, okay. And this is the hard disk. So hard disk is connected with some pass through to this motherboard. Okay, so these are the most important component. I'm not explaining the other components here. These are some slot. Your USB port will be available through this. These are your mouse and keyboard ports. Okay, these are, and this is the main power supply of your computer. And your power point will be connected with this. You can see here, this is the back side of this computer. So you can see this is the you can supply power to this, and this is the fan. This fan is for this power unit. Okay, and this panel is actually the back side of this panel, this panel. So there are, these ports are for mouse, keyboard. This is for printer. These are USB port. These are for audio, video, audio, and microphone, etc. Okay, so you know all these things. And so the main point here is how computer works. And if you remember the von Neumann model that I've explained you previously, I said that everything is stored in memory. Okay, so which part is memory in this computer? So in memory is divided into two parts here: hard disk plus RAM. Both are memory here. Okay, so RAM is called primary memory and the hard disk is called secondary memory. Sometimes RAM is also called main memory. Okay, so if there is a program or suppose or data, and as I also, okay, what I said according to von Neumann, that initially every data is in memory. So if suppose this is the computer and this computer is now powered off, so every data of this computer is stored in this hard disk. Okay, so when you start the computer, first the data will come from hard disk to RAM, and then from RAM to the processor. So this is how it works. Then you may ask me one question, that what is the importance of RAM? Because if initially every data is in hard disk, and when computer means when this processor wants, then every data has to flow from hard disk to the processor, then what is the importance of this RAM? This is a very important question. And maybe why we are going for different size of RAM, because whenever we go for purchasing a laptop, when we go for purchasing a mobile, first question we ask is, what is the size of RAM? 3 GB hai, 2 GB hai, we ask like this, right? So what is the importance of RAM? If the data is stored in hard disk and we have to collect data from hard disk only, then what is the importance of RAM? So this is RAM is important because whatever data you are requesting and whatever data this processor is requesting, the same data processor will request again. Suppose processor is requesting for a data which is called data 1. So first time processor is requesting a data, first of all processor request data through this line and through request to RAM, but the data will not be available in RAM first. So RAM again forward the data to the hard disk. From hard disk, data 1 will come to the RAM first, and then from RAM it will go to processor. Right? This is the first time. But it is highly likely that near future processor will again request for the same data. So in near future, if the processor request for the same data, at that time data will be available in RAM. So in that case, second case, it's no need to go to hard disk because data is already available in RAM. So there will be hit in RAM. This is called hit. Okay, so now what is the advantage of RAM? If you see, RAM is much faster than hard disk. If suppose if there is a processor will go and find a data in RAM, then at least it will be 1,000 times faster than going and collected or fetch a data from hard disk. So that's why RAM is better than hard disk. So that's why the higher the RAM size, more data you can store on RAM, and more data you can access faster. Because if you can access some data from RAM, it will be very fast compared to hard disk. Because you go to hard disk, it is very slow, very slow. I hope this point is clear to you, that Both RAM and hard disk combining, I'm saying as memory. There is another part of memory which I'm not saying here, that will be discussed in next slide. Okay, this is another example of motherboard. I'm not explaining it again. Okay, so now the next question is how computer starts or how computer works. This is how a basic architecture of computer. Hardware I've already explained. If you see this diagram, these all are the hardware components of a computer. So first there is a hardware component, then there is a BIOS, then operating system, then application. So it is not tough to understand. Just ignore the BIOS part now. What is the operating system? Suppose this computer is now working. So this is the laptop I'm using. So this laptop has some hardware. Some there it has RAM, it has keyboard, it has hard disk, everything is there. But when I start this computer, it is working on some OS. Okay. So the way if you use a mobile phone, then maybe it's a Android. Android will be there. So it's a operating system which operates the mobile phone. Similarly, if you are using a computer, then there will be either Windows installed or Linux installed. So these are called operating system, who the operating system purpose is to manage the entire computer. It operates that entire computer. It manages all the hardware components of the computer. Okay. And then what is the application? So application means if in terms of mobile phone, if I explain you, you already have an Android, but on top of Android, you can download many apps. For example, you can download a app from flight management. You can download a app for like Paytm and all. So these are the applications you download to your mobile phone, and they you have to download on top of Android. If your phone doesn't have Android, can you download those apps? No. That means they works on top of these application works on top of operating system. Okay, that's why I've written operating system first and then application. This is how a computer works. But the first basic question is, initially suppose you have a laptop in your house which is now not functioning. That means it is power off. For the moment you press the power button of a computer, how it starts, because if you may observe that when you press the power button of a computer, it takes some time to start the computer. It's not like that car or something, or TV, that you press the button immediately the device is started. It's not like this. Computer takes some time. So what exactly internally happens so that the computer takes some time, and after some time it became ready for you. Okay, so the moment you start the power button of a computer, there is a special program stored in the motherboard. It's called BIOS, and that's BIOS will start. If you go to the motherboard, you'll see there is a battery here. So there is these batteries for BIOS battery. It means that even if you power off your computer, the memory or the content of BIOS will remain there. There is a small memory will be stored in hardware in this motherboard somewhere, where this BIOS program will be there. And to make this content available in this memory chip, there is a battery stored here. Okay, so it means that even if the power there is no there is power, if you power switch off the laptop, switch off the desktop, this battery will keep the BIOS program intact. Okay, so the moment you press the power button, first of all this BIOS program will start. Okay, and this BIOS program, first of all BIOS program will check that whether all the hardware components are intact or not. So you may try one thing. If you have a desktop in your computer in your house, old desktop, what you can do, open the desktop, remove the RAM, and then try to start the computer. What it will do, it will give you a long beep. Long beep means it will show some lines in your monitor, but it will give a long beep. Okay, suppose or you can do one thing, that you just try to remove the hard disk cable and try to start the computer. It will start, it will show some lines in your monitor, and it will show that hard disk not found. So actually these warnings are given by BIOS. So what BIOS do, the moment you press the computer, first of all BIOS program will start. It will check whether all the necessary hardware components are available or not. Means RAM, hard disk, all these things should be available. So it will, sorry, so it will check all these components. First of all, if all these components are available, then BIOS will start loading the operating system. Operating system means, as I already explained, if your laptop has Windows 10, then BIOS will start install means loading OS, operating system. But where from where it will start loading, because operating system is also a software. So initially, all the data of operating system will be stored in a hard disk, right? So one by one, BIOS will start loading the content of OS from the hard disk to the computer. So after some time, when all the data will be loaded, then the computer will be ready for you to use, and you will see a desktop in your computer, and that is called booting. So this process is called booting a computer. So I hope that every one of you have at least started a computer once, so you know that it will take some time. After 30 seconds or 1 minute, it will come, it will see a screen that is called desktop, where you can click or you can perform your task. So this part is called booting. So this is how a booting performs. Booting is BIOS is responsible for booting a computer, loading an operating system on it. Once operating system is loaded, then rest of the thing will be handled by the operating system. So this is how a computer works. Okay, so now if I follow this diagram, the one even architecture, I've already explained you what is input device, what is output device, and different types of memory units I also explained. So what are the memory units I've explained already? I've explained you RAM, I've explained you hard disk. These 2 points are clear to you, but these are not sufficient. There are some other memory units also available which I have not explained you, and these are called cache memories. Uh, this is not cache memory. This is called SSD. This nowadays this hard disk is replacing by this SSD. This is much faster than hard disk. So if you see that most of the recent laptop has SSDs installed instead of hard disk, but this is very expensive. Okay, but still one day this hard disk will be completely replaced by SSDs. Okay, so but one more thing here that I have not explained. If you go to this diagram, I said this is hard disk, this is RAM, but these two are not the memory unit. There are some other memory units also available, and two important memory units are registers and cache memories. So both register and cache memory are embedded inside the processor. If I go back one step more and if I show you this slide and I say that this is an example of processor. So if you go to market and you want to purchase a processor, you can purchase this type of processor. So inside this processor, there is a memory unit called cache memory. Okay, and then there are some registers also used, but registers are the the fastest unit to store some information, and then there will be some cache memories here in this processor. And outside the processor, if you go to this diagram, so here there will be a processor, so cache memory will be inside this processor. But if you go outside of this processor, then you will see a RAM here. So this is not inside the processor. That's why RAM is called off-chip memory. It's not on chip. But cache memory that I am saying now, it's inside the processor, so it's on chip memory. So please remember all this thing, that cache is inside the processor. That's why it's called on chip memory. But RAM is outside the processor. That is called off chip memory. So if I now say just a few slides before, I said that RAM is much faster than hard disk, right? But the same thing is true with cache and RAM also. Cache memory is much faster than RAM. So if you want to suppose if you want to access something from cache, and if it is taking 6 cycles, suppose, then if you go to RAM, it will take suppose 100 cycle, and if you go to hard disk, it will take more than 1,000 cycles. So this is how there is memory hierarchy is designed. So if you go here in this slide, you can see there are memory hierarchy. This is CPU, this is the main processing unit, then there are some registers internally that I will explain in next class. And then there is a memory called cache memory, then main memory which is called RAM, then these are hard disk. So if you see speed will increase like this. That means hard disk are the slowest memory component, then main memory, and then cache are the fastest memory component. Excluding registers are always the most fastest memory. If you go for the size, register is a very small component. Then cache memories are normally from 4 MB to 8 MBs or 16 MBs maximum. Then main memory RAM, you know the RAM size is vary from 2 GB to 16 GB or 32 GB, even 64 GB is also possible in some modern laptops and desktop. Okay, and then go for hard disk 1 terabyte, 2 terabyte. Okay, so now this is how size goes increases, and this is how speed increases. Okay, so So the question here is, why can't we design a bigger size cache, or why can't we go for 1 terabyte of RAM? So the main part here is the cost. The designing a 1 terabyte of RAM will be very, very costly. Okay, so this is the main comment. There are some other hardware issues are also there. I'm not explaining all of this complex region in a programming course, but you can see that the main reason is cost. Okay, you cannot design a 2 GB of cache because of cost, and there are other issues also. I'm not explaining. Okay, so this is how a memory looks like in a computer. So if I go for the main design here, I'm skipping this slide, this is not important for you. So I'll stop here. From this point I'll start next in next lecture. So I'm again going back to this diagram. And why this diagram is important, because this diagram, I said, this is a one Neumann architecture. There are four components. This is the main component, this is a processor component, and this is input, output, and memory. And what I say that everything, whatever data we execute in computer, initially all the data are stored in memory. And one by one computer, the processor fetch data from memory, perform some execution, and then again write back data to memory. But now you know that this memory is not just a single memory. This memory has multiple layer. This memory has hard disk, this memory has RAM, this memory has cache, everything. So it's a hierarchy of memory. It's not just one level of memory, isn't it? It has this kind of, this memory is starting from disk, main memory, cache, everything. So but if you consider make a circle here, then this is your memory, and initially all data is here in memory. Whenever CPU want to do some operation, it will fetch data from this memory. Maybe it will fetch data from here. If data is not here in cache, then it has to go to main memory. If data is not in main memory, it has to go to hard disk. First of all, it will bring data from hard disk to main memory, then it will send data from main memory to cache, and then cache to register, and then CPU. Okay, so and this way computer do or execute its task. And from 1945, the moment of inventing this model, one Neumann architecture, till date, almost every computer follow this, isn't it? Why it is not very hard to understand, because you that every data is in memory. Suppose if, in your computer, suppose it in this laptop I have designed this PPT. Now if I power off this laptop, and after 3 days if I start again this laptop, then again I can see this PPT, isn't it? So it means that all the memories are actually stored in, all the data are actually stored in memory. But there are two kind of memories are there. So you can see this memory disk, hard disk. Hard disk is actually called non-volatile memory. It means that if you store some data there and then you disconnect the power, data will be there. But this main memory and cache memories are volatile memory. This means it can hold data until there is power supply. If there is no power supply, there will be no data stored, all data will be gone. So whenever that you, if you have a computer in your house which is powered off, you always remember that every data stored in hard disk, उसके RAM में कुछ नहीं है, क्योंकि वो powered off है. The moment you start a computer, one by one data will come from hard disk to RAM, then RAM to cache, and then cache to processor. Like this, it works. And that's why we should not off a computer suddenly. What do we do in case of TV? What we'll do, if electricity goes, suddenly TV will shut down, no problem. But this is not true for computer. We have to click shutdown, and it takes some time to shut down a computer. Why? Because if you just plug means shut down means remove the plug point, the power supply from computer, then it will suddenly power off. And if you suddenly power off, then the data stored in cache memory and main memory will be vanished. Okay, so next time when you open a computer, it will show some inconsistency. So if you click shutdown button and you legally shut down a computer, then whatever data stored in cache memory and main memory will be returned back to the disk, that is hard disk, and then it will go power off. And if as I said, disk is a non-volatile memory, so the data will be there in disk. So आप 10 दिन बाद कंप्यूटर रन करो, 20 दिन बाद करो, आपका डाटा डिस्क में ही रहेगा. That's why this the disk is called non-volatile memory. So I hope I have explained you the basic architecture of computer. So next class I will start from this point, and I will explain you how computer execute a particular program. So this will be my next class, and after this, from third class, I will explain you how to write programming, the basics of programming. Okay, so I am stopping here today. Thank you.